Hi guys, my name's Omar. I'm here with Josh and Richard, and today we're going to be discussing agonist and antagonist muscle groups. We're going to start off with a few key definitions to understand how muscles work together to produce and control movements, starting with the agonist muscle. The agonist muscle is the primary muscle responsible for a specific movement. It's the muscle that contracts to generate motion at a joint. An example, take a bicep curl for example. The biceps are the agonist because they actively contract to flex the elbow. The antagonist muscle opposes the action of the agonist. As the agonist contracts, the antagonist relaxes to allow smooth movement. It can also contract to slow down or control the motion, which helps to protect the joint. Continuing with the bicep curl example, the tricep in this case would be the antagonist. Coactivation occurs when both the agonist and antagonist muscles are activated at the same time. Coactivation increases joint stiffness and improves stability, especially during complex or high precision movements. Reciprocal activation is a movement pattern where the agonist is activated while the antagonist activity is reduced. This creates smooth and efficient joint motion. Synergist is a muscle that assists the agonist in performing a movement. It adds strength and helps maintain proper alignment during motion. Lastly, a fixator is a stabilizing muscle that holds the origin of the agonist in place, allowing for a more effective movement of the limb. Muscle actions and joint motion. Joint motion is created when the agonist muscle contracts. The antagonist muscle contracts in order to resist or control this motion, and this is particularly seen at the end of range or during a deceleration phase. An example of an agonist and antagonist pairs, a bicep being the agonist and tricep the antagonist, like mentioned before. Arm flexion, also known as a bicep curl, is when the bicep contracts while the triceps relax. An arm extension would be the triceps contraction as the bicep relaxes. We can also take a look at hamstrings and quadriceps, hamstrings being the agonist and quads being the antagonist. During knee flexion or bending of the knee, the hamstrings will contract and the quadriceps will relax. Knee extensions, such as the straightening of the leg, the quadricep will contract and the hamstring will relax. These muscle pairs work in coordination to stabilize joints, regulate speed of movement, and protect against injury. Applications to biomechanical studies. Understanding agonist and antagonist interactions is critical in the field of biomechanics. It allows us to perform movement analysis for both athletic and clinical populations, study joint stability under various movement conditions, analyze force generation control, especially in sports and rehabilitation, and also in the design effective rehabilitation and training programs that restore or enhance functions. I'm going to hand it off to Richard.
Using the previously discussed relationships, we can look at graphs and analyze them. So in this graph, we're comparing the bicep and the tricep about a joint angle. And as seen from the graph, the antagonist muscle peaks at the end. This allows the muscle to act as a shock absorber, thus preventing injury to a muscle. So here we have another graph comparing the force generated from a bicep curl with respect to its sarcomere length. As previously discussed in class, a muscle is at its highest force output when it reaches the optimal sarcomere length. By quickly looking at this graph, we see that the peak occurs at around 3 micrometers.
This slide here is pretty much demonstrating how data is collected. Typically, you would want to use something such as an IMU, motion sensors, or in this case on this slide, EMG. This particular graph is showing muscle activation versus time for some sort of movement. If we assume that this movement is measuring the leg, we'll say the antagonist in this case is the quadricep, or the antagonist is the hamstring, and the agonist would be the quadricep about the knee. The data collected through the motion study can then be correlated to produce something like this, the force versus time graph showing the quadricep versus the hamstring. Once again, we see the antagonist muscle peaking at the end right before knee break to prevent injury. And then coming back to coactivation, coactivation is the simultaneous contraction of agonist and antagonist muscles. This is typically seen in more demanding movements, so like weightlifting or golf. In these cases, both the antagonist and agonist muscles will contract to help increase the stability of the subject to produce a certain outcome. And to wrap up with some key takeaways, the agonist muscle drives motion about a joint while the antagonist muscle regulates the motion. Force profiles depend on the joint angle as well as movement speed, much like the graphs that we discussed in the presentation. And coactivation is vital for joint protection.